Hello everyone, this is Mrs. Reed and this is lesson 5.3. Our objective for today, I can discover and calculate the properties of kites and trapezoids. A kite is a quadrilateral with two pairs of consecutive sides. Place marks on the given figure to make it a kite. So over here, I would like for you to take a moment and mark this figure with two pairs of consecutive congruent sides. So use hash marks to show that, please. Alright, so I went ahead and marked two pairs of consecutive congruent sides. So these two are congruent and these two are congruent. The next question says, which angles are congruent? Think about the line of symmetry. So looking at our kite over here, I could see that if this is the line of symmetry, then my kite would fold in half right there. And so then this angle and this angle would match up perfectly. And these are called our non-vertex angles. So our kite angles conjecture, the non-vertex angles of a kite are congruent. And we're going to go ahead and mark that on our figure over here. So I mark those congruent. How do the diagonals intersect each other? If you look right here and right here, it looks like they are intersecting at 90 degrees, and if we got out a protractor and we check, this is in fact 90 degrees. So the diagonals of a kite are perpendicular. And we can mark that with the little 90-degree box. Which segments are congruent in length? Again, we're going to think about the line of symmetry. So if this is our line of symmetry, then this diagonal here looks as though it's been cut in half. So these two segments would be congruent to each other. Kite diagonal bisector conjecture. The diagonal connecting the vertex angles of a kite, so from here to here, is the bisector of the other diagonal. So I went ahead and marked this segment congruent with this segment, so I have my hash marks matching up. Which angles are cut in half? Think about symmetry. So again, looking at our kite, if this is the line of symmetry, then this angle here and this angle here are being cut in half, and those are the vertex angles. Kite angle bisector conjecture. The vertex angles of a kite are bisected by a diagonal. And bisected just means cut in half, so cut into two equal parts. So we're going to go ahead and mark that on our kite now. So this angle here is the same as this angle here. I gave both of them 3 hash marks. And this angle here and this angle here are congruent to each other. I gave them each 1. It was hard to make a lot fit. So I'm going to go ahead and add 1 more to both of these. Now we can tell clearly which angles are congruent to each other. Now we're going to move on and look at trapezoids. A trapezoid is a quadrilateral with only one pair of parallel sides. Place marks on the figure to make it a trapezoid. So take a moment right now and put all necessary marks on this figure to make it a trapezoid. Alright, so hopefully you added the arrows like I did. That shows that these two line segments are parallel to each other. Base number 1 has base angles, so this is base number 1, so it has base angles T and R. Base number 2, right here, has base angles P and A. Find the sum of the pair of consecutive angles between the bases. So take a moment right now and do angle T plus angle P, and write it here, angle R plus angle A, and write it here. So you should have gotten 180 degrees for both. So the trapezoid consecutive angle conjecture states, the consecutive angles between the bases of a trapezoid are supplementary, which means they equal 180 degrees when added together. An isosceles trapezoid is a quadrilateral with only one pair of parallel sides, and the non-parallel sides are congruent. Now I want you to take a moment right now and mark the figure to be an isosceles trapezoid. So go ahead and take a minute and do that, please. Alright, so you should have something similar to mine. I like using colors just to help us see what is congruent to each other in addition to the hash marks. Use the trapezoid consecutive angle conjecture, that's what we got over here, to fill in the values for z and I. So here is z and here is I, and remember that z plus d should equal 180 and O plus I should equal 180. So take a moment and fill in the two missing angles. Alright, so you should have gotten 117 for z and 63 for I, which if we look, the base angles are congruent. So isosceles trapezoid conjecture states the base angles of an isosceles trapezoid are congruent. Let's go ahead and mark that on our figure. Alright, so using hash marks we can see that these two base angles are congruent and these two here are also congruent. Because this figure is symmetrical, the diagonals, so this diagonal and this diagonal here, will be congruent in length. So the isosceles trapezoid diagonals conjecture states the diagonals of an isosceles trapezoid are congruent in length. Alright, we're going to go ahead and practice now, starting off with our kites, which if you remember, this angle and this angle are congruent. So this number 3 here that's missing would be 100 degrees. Now we need to figure out this angle up here that is missing, where the 4 is. And to do that, we need to remember that all of the angles inside of a kite add up to 360 degrees. So we do 360, and we need to subtract 100, 120. If we do that, we get 140. So we get 140 degrees. And if you add all 4 of these angles up, we get 360, so we know we did that correctly. Alright, take a moment looking at this kite here and see if you can figure out what this missing segment length is. Alright, looking at the diagonals, this would be the line of symmetry, which cuts this diagonal in half. So then this should also be 10, which means if they asked for it, this entire diagonal length would be 20. Alright, take a few moments here to find this missing side length, this missing side length, and both of these missing angles. So hopefully you looked back at your notes or you remembered that the two pairs of consecutive sides are congruent. So those are congruent, which means this is 4. And then this side is congruent to this side. So AB is 7. And then these two angles are congruent. So to figure that out, we need to do 360, subtract 55, subtract 105, which gives us 200 degrees. Now that 200 degrees needs to be split evenly between angles D and angle B. So we do 200 divided by 2, which gives us 100. So both of these angles are 100 degrees. And if we check, all 4 of these angles should add up to 360, which they do, so we did that correctly. Let's do some practice with our trapezoids. And trapezoids have one set of parallel sides, so that would need to be parallel there. And then we can see that this angle is 57 and this angle is 57, so this is an isosceles trapezoid, which means this angle will be congruent to this angle. Side note, that interesting symbol right there is called theta. So take a moment right now, look at the conjectures we just found about trapezoids and figure out what the two missing angles would be. So to figure out the missing angles, you should have done 180 minus 57, which gives us 123. So both of these missing angles are 123 degrees. And again, that is just from our conjecture about trapezoids. It says these angles add up to 180, and these angles add up to 180. Alright, for our next trapezoid here, we can see that these base angles are not congruent, so it is not an isosceles trapezoid, but we can still figure out the missing angles because W plus Z should equal 180, and X plus Y should equal 180. So take a moment right now and figure out what W and X are. Alright, so 180 minus 54 gives us 126 degrees for W. And 180 minus 60 gives us 120 degrees for X. Looking at this next trapezoid here, we can see that, again, they marked it for us. Trapezoids should have one set of parallel sides, and they marked these two sides congruent to each other, which means it's an isosceles trapezoid. So there are some special things that we know. So go ahead and take a few minutes to figure out what 1, 2, and 3 are. Alright, so the first thing that I did is remember that the base angles in an isosceles trapezoid are congruent, so therefore the missing angle number 3 should also be 73. Next, I remembered that the consecutive angles between the bases add up to 180, so I did 180 minus 73, which gives me 107 for both of them. Alright, and this last trapezoid is off to the side of your paper, so go ahead and turn your paper like mine. And it's a trapezoid, so we have one set of parallel sides, and they marked it as an isosceles trapezoid because we have the two congruent sides, and then we have this information here, over here. Here, I'll make a nice little spot. It says ZP equals 14. ZP is right here. It wants us to find GL. Well, if this is an isosceles trapezoid, then the diagonals are congruent. So GL is 14. So remember to use your notes to help you when you are solving problems like this on your practice problems, as well as when you are doing your summaries. So this concludes our lesson 5.3.